Students, I am Sontu Saha and today I am going to take the Neet Physics Practice Class 1. So without wasting the time, let's start the class. Question number 1. A real gas behaves like an ideal gas if its pressure and temperature are both high, pressure and temperature are both low, pressure is high and temperature is low, pressure is low and temperature is high. This is correct answer. But why? Because potential energy due to intermolecular forces becomes less significant compared with particles' kinetic energy, and the size of the molecules becomes less significant. From property of ideal gas, we know that there is no force of attraction between two molecules of an ideal gas, and the size of each molecule is very negligible, is very small as compared with the volume of vessel. So these two conditions is hold at low pressure and high temperature. Question number 2. Gases obey van der Waals equation. Only normal temperature and pressure, only high temperature and high pressure, only high temperature and low pressure, all temperature and pressure. Gases obey van der Waals equation at all temperature and pressure. Okay, next question. Relation PV equal to RT is given for following condition. For real gas, high temperature and high density, low temperature and low density, high temperature and low density, and low temperature and high at low pressure and high temperature. So answer will be low pressure, low pressure, low pressure. Here no pressure related term is present. So the correct answer is at high temperature and low density. This is correct answer, because the intermolecular attractions and the actual volume of gas molecules becomes negligible at low temperature and low density. And as we know that from property of ideal gas, the intermolecular force of attraction between the molecules is very negligible and near equals to 0. Next question. A box contains n molecule of a gas. If the number of molecules is doubled, then the pressure will. We know that PV is equals to nRT. PV is equals to N by NA. NA is Avogadro number. Okay, Avogadro's number. RT. And here the condition is if the number of molecules is doubled, so N will be 2N. Okay, N will be 2N. From here we see that if V equal to constant, volume is constant, then the equation variation of P varies N, because NA is also constant, Avogadro's number 6.023 into 10 to the power 23. So if number of molecule is doubled, then pressure will be doubled. Okay, so pressure will be doubled. This will be answer. Okay, next question. The volume of an ideal gas is V at pressure P, temperature T. The mass of each molecule of gas is M. The density of gas will be K is Boltzmann constant. We know that PV is equals to RT. V is equals to mass by density and RT. Okay. Actually the equation is nRT. Here nRT, and N is equals to M by M RT. Capital M is molecular weight. Okay, molecular weight. Next, P by D is equals to RT by M, because cancelled. Next step is P by D is equals to K N A T by M, because we know that R is equals to K N A. K is Boltzmann constant and Na is Avogadro's number. Okay. In next step, T is equals to P M by K N A T. Here M by Na is equals to small m by Kt. What is small m, sir? Small m is mass of each molecule. Okay. For a particle executing SHM along x-axis, force acting on it is given by, we know that F is equals to minus kx. Why minus? Actually force varies as minus x, and F equals to minus kx. Let there is a spring of spring constant k and the mass is m. If you apply a force here, or due to its weight, the elongation of spring is x and F is equals to minus kx. This force is restoring force. This force is responsible to bring this mass at its previous position, and the motion of this spring and the bob is a simple harmonic motion, SHM. Okay, so F equals to minus kx. The equation of motion of a particle executing SHM, d2x dt2 plus x by k equals to 0. The time period of the particle will be, we know that d2x dt2 plus omega square x is equals to 0. This is the equation of SHM, and comparing this equation and this equation, we get omega is equals to, omega square is equals to 1 by k, and omega is equals to root 1 by k. Again we know that omega is equals to 2 pi by t, so t will be 2 pi by 1 by root k. So the answer is 2 pi root k. This will be correct answer. Okay. Next question. The displacement y of a particle varies with time in second as this equation, y equal to 4 sin pi by 2t plus pi by 3. And the question is, the displacement y of a particle varies with time t in second as, oh, same question here. Okay, the time period of the oscillation is, okay, as we know that equation of SHM, y is equals to 4 sin, y equals to a sin omega t plus phi. Phi is initial phase, okay, and y is displacement. Comparing this equation and this equation, we get omega is equals to pi by 2, and a is the amplitude is equals to 4, and again we know that omega is equals to 2 pi by t, pi will be cancelled, so t equals to 4 second. Okay, this is the answer, so 4 second. Next question. Two particles execute SHM along two parallel lines at the same frequency and same amplitude. Okay, in this question the concept used here, actually simple harmonic motion occurs when the restoring force F is equals to minus kx is directly proportional to the restoring force, directly proportional to the displacement from equilibrium. Okay, and the equation of displacement in SHM is given by x equals to a sine omega t plus phi. Given that they cross each other at the mean point, okay, and they move in opposite direction at the mean position. So at mean position x equals to 0, and from here putting the value of x we get a sine omega t plus phi. Okay, so omega t plus phi is equals to 0 degree or 180 degree. Since the two particles are going in opposite direction, the phase for one is 0 degree and another is 180 degree. So phase difference will be 180 degree minus 0 degree is equals to 180 degree or pi. Okay, actually in this case these two types of oscillation occurs. Okay, the amplitude is same. Okay, and this is mean position for A and this is mean position for B, and when they oscillates and the displacement from mean position is 0, then it moves this direction and the A is moving in this direction. So at x equals to 0, the direction of movement in opposite, as we see here, this line, they move in opposite direction at the mean position. Okay,